Hello everyone, I am SHUBH NIMBAL and I will today explain the topic resistive transducers. First of all, I'll explain about transducer before going to resistive transducer. Basically, it's a device which converts one form of energy to another, and the process is called transduction. Resistive transducer basically see the change in resistance and convert it into change in some other physical quantity. And resistive transducers are devices in which resistance varies due to effect of physical quantities to be measured, and these physical quantities can be temperature, pressure, displacement, vibration, force, etc. Now, basic working principle of the resistive transducers are basically using the calculations of temperature, displacement, pressure, force. The working of resistive transducer can be explained by considering a conductor rod on a as a transducer. The transducer works on the principle of length of the conductor, and here you can see the formula rho is equals to L by A. The resistance is directly proportional to length and inversely proportional to A, the cross sectional area, and rho is the resistivity. And the resistance of the transducers can vary because of uh, the changes in environmental conditions as well as the physical properties of the conductor. Measuring devices like AC or DC can be used to measure the change in resistance. Now here comes the resistive transducer circuit. The resistive transducer circuit consists of long conductor whose length can be varied with time. One end of the conductor is connected while the other end is connected to a brush or a slider that can move freely along the length of the transducer. And now comes the advantages of the resistive transducer. They're very quick, they give very quick results, and are available in various sizes, and they have a considerably high amount of resistance. We can use them both in AC or DC for calculating the changes in resistance. They're quite affordable, like they're not that expensive and can be easily available in the market. We can use the transducer in various applications even when they are not a necessity. It can be used to give accurate results. And disadvantages are a lot of power is wasted in moving the sliding contacts. The sliding contacts can also produce noise. Now we come to the applications of resistive transducers. Resistive transducer is mainly used to measure the temperature in various kinds of applications. When there is change in temperature coefficient of the resistive transducer changes, which can be used to determine the change in temperature. Now the one more application is in the potentiometer. It can function as potentiometer, where the resistance of the transducer can be varied by changing the length of the conductor. As we have already discussed the proportionality of length with respect to resistance, and a resistive transducer can be used in the calculation of displacement. When we apply strain on the resistor, the resistance changes. The characteristic can be used in the measurement of displacement, force, and pressure. Now, examples of resistive transducers are many, but I have mentioned two of them in my slides. The first one is thermistors, and the second one is strain gauge. First, thermistor detects change in temperature and then converts into the change in resistance, and then strain gauge convert pressure, force into the change in resistance. Now, the thermistor is a resistance thermometer or a resistor whose resistance is dependent on temperature. From the term also we can understand it's thermistor. So thermal and resistor. It is made of metallic oxides pressed into a bead, disc or cylindrical shape, and then it is used here in with an impermeable material such as epoxy or glass. Now, advantages, disadvantages, and applications of thermistor. Here, the main advantage of thermistors are basically I have mentioned few, but there are many advantages. Large temperature coefficients of resistance is one of the advantages which is there in thermistor. High sensitivity, small heat capacity, fast response is also there in thermistor. The main disadvantages are poor interchangeability, non-linearity of thermoelectric characteristics, which is to expand the measurement. And now applications. You might be aware of many of them, but I'm still mentioning them, and you can refer to some of the applications which you don't know. They can be found in everyday appliances such as fire alarms, ovens, and refrigerators. There are also used in digital thermometers and in many automotive applications to measure temperature. Now comes strain gauge, the second one. A strain gauge type transducer converts physical quantity such as load, pressure, or displacement into mechanical strain on the strain generated body, and the mechanical strain is converted into electrical output using strain gauges mounted on the elastic body. And also I have attached one image which you can refer for the strain gauge. Now comes the advantages, disadvantages, and applications of the strain gauge. First of all, come when we see the advantages, there is no moving part here, so it is a big advantage here, and it is not that costly, also small in size. And disadvantages, it's non-linear behavior and it needs to be calibrated. And applications are in testing ship hulls, vehicles testing applications, structural component testing, construction applications are very important using this device. And I thank you all to listen very patiently, and I hope you liked my video, and also my video was informative to all. And thank you guys.